So when we're talking about differentiability, all right? So we've talked about what the limit of the, remember, if we revisit, right, the limit definition of the derivative, right? The limit as h goes to 0 of f of x plus h minus f of x. The natural thing we have to think about sometimes is whether this limit even exists or not. So we say a function is differentiable at a point. So f of x is differentiable at x equals a when f prime of a exists. Now, it might seem obvious, like, okay, so what are some things that might cause it to not exist? So we really want to focus on when would the, I think what I usually like to think about is when might a derivative not exist? So this is a limit here, right? Okay, so let's plug in a. Let's say f prime, instead of x, let's put in a. F prime of a is the limit as h goes to 0 of f of x plus a minus f of a over h. Okay, so one criteria that has to be met in terms of this is in order for the differentiable, it has to be continuous. And we could talk about the three ways. Remember the three types of discontinuities, right? We have a removable. Okay, we have infinite, and we have a jump discontinuity. Basically, you can prove that this limit isn't going to exist if either of these are true. But basically, what's going to happen is this limit won't exist if anytime any of these are true. Because if you try to compute the limit, you'll find that it won't work, basically. Like, the limit won't exist. Like, for example, for an infinite discontinuity, like, f of a doesn't exist at all. Okay, that's when I have a vertical asymptote at that point. So that doesn't exist. So that this value I can't even compute. Therefore, this limit isn't going to work, right? In a jump discontinuity, basically that this difference won't exist from the left and the right in order to be different from the left and the right. So it'll be left and right limits won't match. And then for a removable discontinuity, again, the limit will not exist. And the key thing to remember for discontinuities, another way, remember, because what this thing is about the slope of the tangent line. If I have a point in a curve like this, if I have a jump discontinuity, there's no tangent line. I cannot compute a tangent line at this point. You can't, because to the right side it won't exist. And same with an infinite discontinuity or even a removable discontinuity like this. There's no slope of a tangent line. That limit basically won't exist. So it's not differentiable if it's not continuous. But it could be continuous and still not differentiable because the limit from the left and the right of this might not match. And so that's the case if I have a corner. If I have a corner where like the slope kind of changes right at this point immediately, that what's going to happen is this limit doesn't exist because if you look at the limit from the left, okay, limit as h approaches 0 from the left, and you look at the limit as h approaches 0 from the right, it won't match. Oops, I didn't spell match correctly. Won't match. So if it doesn't match, remember by limits, if the left and the right doesn't match, then the limit itself doesn't exist there. Okay, so that's what would happen in a scenario like that. The last time the differentiability will not work is if it has a vertical tangent line, because the slope itself will be infinite. So if you have a point here where the tangent line is vertical, okay, because the vertical slope, that also the vertical tangent line, the derivative doesn't exist because the slope of the tangent line would be infinite, right? This limit would be some kind of infinity. Okay, in that scenario. So basically, just to summarize, the three ways that it could be, so it could be not differentiable if A, it's continuous, no, or it's not continuous, or B, the slopes from the left and right don't match, or the tangent line is vertical. So it has an undefined slope. In all three of those cases, the slope of the tangent line will not be defined. There's no way to establish the slope of a tangent line, and that's when it would not be differentiable. Now, in the case of, in a very particular case, like sometimes you get problems for differentiability where you have a function where from the left and the right, you want to show that it is both continuous and differentiable. So it might look like this, like it's a piecewise function. Like it might be like ax plus b, and it might be 3x squared plus 4 for x less than or equal to 1 or x is greater than 1. And the question we ask ourselves is what values of a and b would make it make it differentiable at differentiable everywhere, right? And so the thing is when you have a piecewise function, we really care about this boundary when we switch between two functions. So I would have to look first. I would want it to be continuous first. So we wanted to check continuity, because in order to be differentiable, it has to be continuous, right? Because it's not continuous, it's not differentiable. So I want to do the limit as x approaches 1 from the left of f of x should equal the limit as x approaches 1 from the right of f of x should equal f of 1. We need all three of those to be equal for it to be continuous, right? So the limit matches the value of the function. So from the left, you're going to plug 1 into this guy because that's less than 1. So that's a plus b. From the right, I get 3 plus 4. And if I plug in 1, I'm also going to plug in 1 into here, like f of 1, because this is the equal sign, is going to be a plus b. So a plus b equals 7. Okay, I can't solve for a and b yet, but the other part is the slopes need to match, right? So then you would take the limit as x approaches 1 from the left of f prime of x, and look at the derivative of this guy from the left. That would just be a, by, because derivative of ax plus b is just a. And then the limit as x approaches 1 from the right of the derivative, that's this function here. Derivative of this is the limit as x approaches 1. What's the derivative of 3x squared is 6x. If I plug in 1, I get 6. So that tells me here, for these two slopes to match, a has to be 6. And therefore, if a plus b is 7, then b has to be 1. Okay. So I hope that helps there. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.